So we've connected GeoEvent to the outage management system. We've pulled in these points. There's 54 million of them. Can't do anything with desktop on that. Can't do anything really with a single server of that. So we're going to take it into GeoAnalytics Server. And Harry's going to show us what GeoAnalytics Server can do with 54 million points.
Yep. Okay, 54 million points stacked on top of each other, displayed in a web map. That's a lot of information. So how can we begin to analyze this and make sense out of it to try to make a decision? Well, when I was presented with this number of points, the first thing I thought about doing was running a hotspot analysis, because that's something that I've been trained to do. Because we're using GeoAnalytics, what that means is under my analysis tab, when I click on feature analysis, I see standard tools and GeoAnalytic tools. Standard tools are not using the parallel processing. They're just the standard tools. But under the GeoAnalytics tools, these are all using those other servers that are in the cloud. So we have typical tools like summarize within and aggregate points. And the one I want to look at, though, is analyze patterns. And that's the find hotspot. So the first thing I'm going to do is browse for a layer. And I'll type in customers. Now, there's something that I really need to point out. You'll see this symbol for the three stacked servers. That means that this is in a file share and it's being managed and it's connected to that spatial temporal data store. So customer outages, this file share, it does not live on my laptop. It's in that new optimized format to be able to perform analysis. So when I select this layer, it's not being brought into my web map. The data still lives in that spatial temporal data store in the file share, and that's where the analysis will be ran. So we can select the standard bin sizes of 5 miles and 5 miles and so forth. And start time is a good way to look at the heat map the heat map for the analysis. Now, I'm not going to run the analysis. Anyone want to guess how long it took to run this on 54 million points? Just go ahead and shout it out.
We used one server, 4-core server in the Amazon cloud. Anybody want to guess?
45 minutes. Who said that? 4 to 5. Oh, it was 45 minutes. I was like, what? No, it's actually higher than 5 minutes. 10 lower than 10 minutes. Can I get somebody to go to 5? 5.5 minutes. Can I go to 6? 6.5. 6.5. 6.5 minutes is correct. Yes, it is. So it took 6.5 minutes to run a hotspot analysis on 54 million points. And let's see what that looks like. There it is. So is anybody familiar with the Houston area? Yeah, why did this hot spot analysis look like that? Population, yes. To prove that, let's go ahead and add some data to the map. We're going to browse our living atlas, and I'm just going to search for population. And I'll add the population density directly to my map. So we ran this analysis. It only took 6.5 minutes, and we came up with this hotspot, and we realized, hey, maybe this isn't the best way to analyze the data. Because if I turn off the hotspot, you'll see that there's just more people there. That's why the hotspot is there. But it's okay. It only took 6.5 minutes. We didn't have to wait a week to run this analysis. So now let's look at doing some more analysis. Go back to the analysis button, feature analysis, GeoAnalytics tools. The one I want to look at is aggregate points. I will once again go out and find those customers. And again, it's in a file share using our optimized spatial temporal data store. I'm also going to select hexagons. So hexagons are a great way to begin to aggregate data. If you want to learn more about why they're maybe better than other formats, you can come talk to us afterwards. And then I'm going to aggregate some statistics on different fields of my data. So all of the fields here are on the data that's being stored in that new format. I want to look at outage minutes, and I want to add up all the minutes that the power have been out in one of those little hexagons. I also want to look at outage minutes again and find out what the average time the power has been out in each one of those little hexagons. And then to continue this, look at this idea of momentary outages, which are, again, the ones that are not planned. I'm just going to do a quick count on those as well and sum them up. And then we'll just do another count on the momentary outages as well, or on the outage minutes as well. Straight count.
So we're doing 1, 2, 3, 4, 5 different calculations, all with a single process, right?
Now, I'm not going to run this analysis, but it only took 4.5 minutes to aggregate those 54 million points into each one of these hex bins.
So before we look at those, let's back up a little minute and say, so we're doing this proactive data exploration, right? And by the way, we talked to CenterPoint Energy, and every electrical utility has outage information, and it's just like the 311 data. Nobody's analyzing it, right? And it's too large to analyze. Now, why would an executive of CenterPoint Energy be interested in this? Because if the power goes out, I can't charge them for that power, right? So that's lost revenue. The other thing is if I'm a customer and my power goes out, I'm not happy, right? So we're dealing with customer satisfaction and we're dealing with lost revenue. So if I can extract value out of this data so that I can make decisions and lower these outages, I'm going to increase revenue and I'm going to increase customer satisfaction. Two very important things for help me keep my job, right? So when we were working with CenterPoint Energy, as we worked through this, they started to see the huge value they had locked up in this outage data that they had never been able to analyze before.
Yeah, exactly. And because it happens so quickly, you can just continue to run this.
Right.
So let's look at this data. Here's the aggregated total outages. So the dark blue area means that there are more outages, right? So in this area, there was 80,000 outages. And remember, even if your lights flicker, that's considered an outage. That's why these numbers are so high. When you go out into the outskirts of the area, you'll see there's only 23 outages. Again, this is following population. There's more outages where there are more people. So let's look at the aggregated outage minutes, the total number of minutes the power has been out. So here it's about 4.7 million minutes that the power has been out. And on the outskirts, you'll see, it's only 8,443. Again, this is following that pattern of population. So it's good, but maybe I'm not able to derive as much information out of it. So let's look at the average outage minutes. So every time the power goes out, how long does it go out for? We see a very different story now. If we come into the Houston area, every time the power goes out, it goes out for only 20 minutes. But when we go into sort of more of the rural outskirts, it goes out for 1,000 minutes every time the power goes out. Does anybody know how many minutes are in a day? Well, there's a lot. I don't know the actual number. I was hoping somebody would tell me. But I think there's like almost 1,200.
Yeah.
So what that means is almost an entire day worth of electricity. That's your freezer starting to melt. That's your food melting. That's no electricity for lights if you have to do things outside or even inside.
So this is actionable insight that executive would want to see and say, hey, we have an issue out here. We've probably got some upset customers because they're losing power for an entire day when it goes down. We need to figure out what's going on and we got to fix that.
Yeah, so we can begin to help prioritize. Because remember that diagram Adam showed in the beginning where it was a circle and said planning, and we can use ArcGIS Pro? Well, we're doing that right here. We're beginning to understand where should we go and look? Where should we go and address issues of power outages? So this is very insightful. So now the idea of momentary outages are very important as well. So what this map is showing us are the location of momentary outages where those lights flicker. So once again, it does follow population. So out of the 201,000 outages, 167,000 were momentary. Out here, out of the 96 customer outages, 63 were momentary. So this is being mapped on the total number. That's why the outside areas are not as bright white as the inside. But let's use some smart mapping to change this momentary outage information and add other variables to it to tell a bigger story. So the first thing I want to do is select the right one. Is begin to symbolize this theme a little differently. So right now it's just going from white to blue. I want to divide by the total outages. And what that's going to do now is to not give me a raw count, it's going to give me a percentage. And a percentage is a better way to look at many figures. So we can see now the lighter areas have a higher percentage of momentary outages. To make this map just look a little better, I'm going to use a theme called extremes, which will then color the different extremes now for me. Again, the blue areas, higher percentage of momentary outages than total outages. For the transparency, I'm going to add a field for my transparency on the total number of outages. And I'll select 0 for the high values, and hit OK.
That's pretty cool to be able to drive transparency by a field value, right?
So now what we can see from this map is, again, the blue areas, higher number of momentary outages. The brown areas are higher outages. But the transparency is now telling us the total outages. So in the area where there's less transparency, we have a high number of outages. Remember, this follows the population. This makes sense. In the areas where there is more transparency, it means there are fewer outages overall. So now that we've made this web map here, this is something that we can begin to share with other people in the organization, and we can create a web app. And I'm not going to do that because we've done it 100 times already today, it seems like. But we can go ahead and just share it with the others in the organization to help make those decisions.
Right, and so you can give this in a web app to a manager or an executive that could interrogate it themselves, right? All right, so GeoAnalytics Server adds premium server capabilities. You would need ArcGIS Enterprise, your portal for ArcGIS, and then GeoAnalytics Server. Dramatically reduces processing time. None of that analysis was done in desktop. That was just done in a web browser because it's all being done on the server, right? It's using the exact same GP tools we've always had available to us. They've just been rewritten to be faster and use the spatial temporal data store. Makes your unusable data usable. Again, that data was so large we couldn't effectively use it. And I saw Jack present on this kind of topic, and he was talking about how, you know, when you're executive and you're looking for insight in your data and you got this large data, it's like looking for a needle in a haystack, right? By doing this, you burn down the haystack and find the needle right away, right? So that's the kind of ways that we're trying to get you to understand that you can explore this data, analyze it, and really extract some valuable insight that executives can use to make those decisions.